And if you have any question, you can just write them in the question and answer box, and I will transfer them as a moderator to the speaker, to our speaker. Our honorable speaker is currently working as an assistant professor at Muhammad Ali Jinnah University in Pakistan, and he's expert in many areas. He worked as a marketing and business instructor, digital marketer, business analyst, and technology marketer, business researchers, and Spss trainer, and also as SEM trainer, and finally artificial neural networks instructor. He published more than 20 publications. Most of them are under Index Scopus publication. So today, let's welcome our honorable speaker, Dr. Kashif Farhat.
Thank you. Thank you, Amal. Thank you for giving such a nice introduction of mine. I'm quite humble to be here to join you guys and help you guys in terms of SPSS, even though it's about data analysis and understanding how data works in research. So please allow me to share my application. Okay, there you go. Sharing an application with you guys. Okay, so I hope that you guys can see my presentation.
Yes, we can see.
You can.
Yes.
Okay, perfect. So let me start. Okay, so Bismillah ar-Rahman ar-Rahim. It's very important that we understand the context of this session today, a sort of workshop where we'll be talking about SPSS, and we'll be talking about some of the very basics of SPSS, and then from basics we'll move on to a point where we'll be running analysis and figuring out, what type of data we need and what type of analysis do we need and what kind of modeling we can do in SPSS. So all together today we'll be talking about SPSS, and we'll be talking about what we can do in terms of data analysis using SPSS. Okay, so this is my humble introduction. My name, my name is Dr. Kashif. I have a PhD in marketing from University of Tara, Malaysia. So I'm the alumni of UUM, and just last year I received my degree, my school. So officially, I did my PhD in 2021, even though I did my Bible back in 2020. Currently, I'm working. I'm serving Muhammad Ali Jinnah University, which is a higher education institute here in Pakistan, Karachi, Pakistan, and I've been serving this university for the last 8 years. Currently, I hold the title of assistant professor. Like you can see on the slide here, I'm also active in business research, specifically in marketing, and you can see many of my research have come in the last couple of years because this was part of PhD, but it is also a lifetime commitment. As a PhD, one is supposed to have a lifetime commitment towards research in his area. So my area of interest have been usually most of it have been customer brand engagement, brand community, and also higher education, marketing. Beside this, before moving to academia, I was part of many organizations, and mostly I held sales and marketing position. And I was also fortunate to be able to be a part of a team where we were doing digital marketing back in 2013. And like the reason I call it, I was fortunate because now I realized that back in 2013, probably not many people even knew what digital marketing is, and I was doing it. Okay. Okay, I'll just take a minute break because I have an adhan, going on here. I'll just take a minute break. Okay, so continuing from where I left off. So this in this workshop, what is the context of this workshop? This is very important. So just like you, when I went to UEM 5 years ago, approximately 5 years ago, what I realized that one of the biggest challenge for postgraduate student was to deal with data, which is everywhere in the life and everywhere in research, especially when the students deal in final year projects, their research projects and thesis. This is where they have to deal with data. And I believe most of us understand that we have two types of research going on, and that one is the qualitative part, and the other one is the quantitative part. And today, the focus of our discussion is quantitative part, where we use quantitative to collect data. Either we collect data in the form of text and then we convert into quantitative, or we directly collect data into quantitative and then we crunch that data, we analyze that data to figure out, to understand what is happening and to understand, to conduct our research. So for master student, even though it is a if somebody who's at master level and doing his thesis or her thesis, usually they can have a rudimentary, some basic knowledge of the statistics and research, and they will be able to conduct their research. However, when you compare it with PhD or a doctorate student, it's a matter of championing the data analysis, which essentially means they need to have more than average knowledge of exploring and crunching data and employing various types of statistical tests to figure out what is going on in their research. Specifically, quantitative research is dependent on conducting statistical analysis of data, whether your focus is sample or population. So this is the outline of what we'll be doing today. Basically, SPSS allow us to run a number of different type of statistical analysis, and the number of these statistical analyses are, I would say, essentially unlimited. So, if I say hundreds or unlimited, this gives you an idea how powerful SPSS package is, the software is. So today, what I would like to do is that I would like to show you how to run different type of descriptive statistics, and then how to run outliers analysis, and then how to check data distribution, which essentially means normality of the data. Then I would like to show you how to do data reliability, and then how to do data validity. Then I would like to move on, and I would like to show you how to do different type of regression analysis, and specifically OLS, ordinary least star regression, also commonly known as multiple regression. And then we'll be doing logistic regression. Also, in a short form, we call it logic regression. Okay, so when postgraduate students conduct the research, they're faced with a number of challenges. They're asked to do data cleaning, they're asked to do data exploration, they're asked to do data analysis, and they're also asked to do, now the quite common is PLSM and CDSM. And in this, SPS is extremely helpful. So there are two paths of research, a postgraduate student can take. In on the first path, they may be using SPSS, exclusively SPSS for their research, and they may not need any other software for that. On the other path, they may be using SPSS as a primary or support tool to explore data, to run different type of preliminary analysis before they jump on AMOS or Smart PLS, which is PLSM, for their data analysis and check their hypothesis, whether their hypotheses are true or false. So SPSS is extremely essential, primarily for data cleaning and exploration, and various data statistical analysis such as regression and correlation, etc. On the other hand, SPSS can be the first tool you want to, student, a postgraduate student, specifically a PhD student want to use to run their data analysis, to run their preliminary data analysis, such as data cleaning and exploration. And later on, they want to use that data. Later on, they want to use that data in Smart PLS or for PLS SEM to run further analysis. Okay. So where exactly we deal with SPSS? Where exactly we deal with SPSS? Now we understand that a PhD thesis, depending on your field, but most commonly a PhD thesis is divided in 5 components. The first component is called introduction. The second component is called literature review, and third component is called methodology. So where students exactly start dealing with SPSS or data, mostly they start dealing with SPSS and data, or SPPLSM is in their methodology. This is where area when they sit down, they start writing the methodology. They need to build enough knowledge of what type of data they may need to conduct their research, and what type of analysis it may require, and what type of skills it may require, and uh, what are the downside, what are the pitfalls they need to avoid. So when a student reaches methodology section, this is where they need to start learning all these. Even it's even better if they start learning before, but I always suggest to them, having gone through this process many times, I always suggest that when you start conducting your research, before you submit your research proposal to your supervisor, to the examination committee, make sure you're pretty clear about your methodology, and make sure you understand A to Z of your methodology. And in order to do that, you need to understand what type of data you need, what type of analysis you'll be doing, what type of software you'll be doing, what are the downside and upside of different software, different analysis, so much and so on. The more knowledge they have, the better they'll be able to write a methodology of their research proposal, and better they'll be able to conduct their research later on. Because often it happens the student claims a lot, the student promises, students promise a lot in their research, in the research methodology, and later on when they start collecting the data, they come across a different type of situation and problem, and then when they start crunching the data, analyzing the data, they realize they need to change methodology, and the problem, and they figure out the problem lies in not knowing enough about the data when they were writing the methodology section. So very important when student writing methodology section, they need to understand what type of data they'll be collecting, and what type of analysis they'll be doing, and what it requires to collect that type of data. Okay, so essentially, students do, they when they're doing methodology section, they need to understand what type of cleaning data steps they have to take, what type of steps they have to take to do the cleaning of data, what type of assumption, or underlying assumption are there for various type of tests and analysis of the data, and what type of tests or analysis or the modeling they'll be doing, regression, PLSM, or any other type of modeling they'll be doing. And they need to understand what type of what type of reporting it requires, and they need to understand that what type of hypothesis they have built, and according to the hypothesis, what type of analysis are required. So keeping in mind the needs and challenges of a postgraduate student, anywhere around the world, I've set this presentation and workshop here, and I'll be running various processes. I'll be going through various steps, demonstrating to you guys to make you understand what are the common steps a student will be taking or should be taking when they're doing their when they're doing their data analysis, and specifically when it comes to using SPSS. Okay, so we'll be starting with what we're doing first. First, we'll be doing some of the basics of SPSS. We'll try to figure out what SPSS is. I'll show you the layout of the SPSS. Then we'll do the data screening, and then we'll do the descriptive analysis, and then we'll be running correlation, and then data reliability, and then data validity, and in the end, we'll be doing multiple regression, OLS, and logistic regression. Okay, so from here, I'll move on to SPSS. Give me a second. I'll just go ahead and run my SPSS. SPSS. Give me a second. Okay. Here.
Yes, doctor, everything is clear.
Okay, perfect.
Proceed. Yes.
Perfect, thank you. Give me a second. I'm turning my SPSS on. It's a bit slow. SPS is a type of software which requires, takes a lot of your RAM, a lot of resources in your laptop. So it's a recommended laptop or desktop, whatever you're using. It's recommended that when you're installing SPSS on your laptop, you have minimum 4 GB RAM and you have enough space in your disk, and you don't have a lot of other softwares going on at the background. So that way you're able to run the software quickly and you get your analysis pretty fast. Otherwise, it's often the case, the SPSS gets stuck or your laptop gets stuck. Like I'm in a situation right now where SPSS is a little bit slow. I'm just waiting for it to start. It's reading.
Doctor,
Yes.
but we
Yes.
can't see anything in the screen.
You can see, just give me a second. I'm starting SPSS. Just give me a second.
I thought there's something.
Okay, just give me a second. I tried to stop it already. So I'm going to stop sharing my slides, and then let's see if I have SPSS going on. So sorry. So soon, I'm really sorry for this delay, but as soon as SPSS comes back, I'll be sharing my SPSS screen with you. Okay. Can you see my video now?
Yes, doctor, we can
Okay.
see your video. We can see you.
Okay. Okay. Perfect. Just give me a second. I have the SPSS almost ready. Almost ready. Okay, so I'm going to share my screen. You guys, I hope you all can see SPSS now.
Yes, doctor.
Yes, doctor. Clear.
Okay. So let me give you an overview of what SPSS layout rather. You see, that's how you see here. I have two views. One is called data view. The other one is called variable view. Yeah. So data view is just like SPSS, Excel sheet, just like Excel sheet, where I have data for each of my. So this data is for survey research data. So mostly in business research, mostly not always, mostly in business management such as HR, entrepreneurship, technology management, marketing. These are the areas we often, just simple management even. This is the area we often do our research using different type of survey question. So when we do our research and survey question, this is the type of data we have it. This is the type of data get it. So what I've done is that I have moved that data to SPSS, the software you can see. So on the data view, you see all the data that I have received from my respondent. And the variable view, here, you see the variable view. This is the place where I can change the name of my variable. I can change the name of my variable. These are the original variables. So customer satisfaction 1. These are the original. So my variable 1 is customer satisfaction. Variable 2 is food quality. Variable 3 is perceived value. Variable 4 is ambience, and variable 5 is responsiveness. And each this customer satisfaction 1 represent the one item, the one question for the customer satisfaction, and customer satisfaction 2 represent the second question for customer satisfaction, and so much and so on. Same is for food quality, and same is for perceived value. So here, what we can do, there are a couple of ways. We can go here and just open and data, and we can simply import any. Excel sheet. Other way around is that okay, this is still stuck. Okay, just cancel it. So we can open it. Other way around that we can simply copy and paste our data here. And once we copy and paste data here on the data view, we just go here, and according to here we'll see some random name, and then according to our list here, we go one by one, and we put the right name to our data. And then we go here, and we just leave it to numeric. We make sure it is numeric. It's not anything else. If it is anything else, it will change your result. It will give you many errors. So we just want to make sure that the name is as it is on our survey questionnaire, and then we have the data type is numeric. Width could be anything. Decimal, we don't need to care about it right now. And then label. Label is the one. For example, for each of this item, we have given a label here, and label is a short form. It's a coding. In other words, it's a coding. So for customer satisfaction 1, we're giving a code of CST1. For 2, we're giving CST2. Same is here in PV. Same as here in ambience. So what it does, it's not required. It's an optional that we can give any label to each of our item on our questionnaire. So when we'll be running our analysis in reports in the tables, we'll see the coding. We'll see these coding. We'll not be seeing these here, right? Because these are 2 long names, and often it just these names just disturb the structure or the layout of the table. So it's recommended that we have put these type of label here for each of our items, right? So when the table, when we're doing analysis, the table come out in front of us. We know CST1, CST2, CST3 means the third or the fourth question of our customer satisfaction variable. Okay. The other thing what we want to do here is have a look at this. I'll click here, values, and this is very important. Very important. So let me remove all of these just to show you how did I do that. Okay, so I'm removing all of these. Okay. So the other thing what we want to do is when we put the data here, remember usually we collect data on Likert scale, or Likert scale or Likert type scale, right? So if we are collecting data as Likert scale, Likert type scale, so often the values goes like this. So this is what we need to tell Spss, that 1 means strongly disagree, okay, and this is the common one. 2 mean disagree. 3 means neutral. 4 means agree. And 5 means strongly agree. If somebody using 7-point Likert scale, they can do the same. If somebody is doing 3-point Likert scale, 6-point Likert scale, 9-point Likert scale, they can do the same. It doesn't matter. But we have to tell SPSS. In order to run many type of analysis, we have to tell SPSS what type of scale we are using. And let's click OK, and you can see this now. You see this values here in front of this. I am telling SPSS that I've collected this data like this. So SPSS will now analyze my data accordingly. Now look, I've done same here everywhere except for wherever I have Likert scale. But when I came to gender, I used a binary one. I said female is 0 and male is 1. And the same I did. So this is called binary. It's called binary, and it's also called dichotomized. And then here in education, I have put these type of we call interval scale. Okay, so interval. This is where I'm doing Likert scale. This is where I'm doing binary, or we have only 2. We have male, female. For that, we have done 0 and 1. And here I have ages, and I have 3 level of ages, and I put 1 for 21 to 30. I put 2 for 31 to 40. I put 3 to 41 and 41 to 50. It's really up to you. If you want to add more, you can add more. If you want to add the 4th one, which says, let's say you want to say 4 is, well, use 4, and you want to say, for example, you want to say 50 and above. You want to call it, you can add it. No problem. You can add that. There you are. If you don't want to add like this, you just want to keep it simple, fine, depending what type of data you're collecting, what type of questionnaire you have. And same I've done for education here, 10th grade, bachelor, master. If you want to add more fields into that, PhD or somebody less than 10th grade, you can add that. Likewise, I have occupation going on. I have many occupations listed here. For each occupation, I've given a number and I've added them here. Okay. Let's ignore them for these 3. Let's ignore for now. Okay, another thing we want to make sure so this is the data view and this is the variable view we're working on. The other thing we want to make sure is that when we're selecting, this measures for these Likert scale questionnaire until here. We have selected scale, not ordinal. We just want to make sure that scale, this is all scale. But when we come here on the gender, this is nominal. And this goes to the basic statistical inference, where we understand what are the different type of data scale, what are different type of variables. Okay, so we have nominal here, we have nominal here, we have ordinal. It doesn't matter. If you want to keep it nominal here, you can keep it, but just want to make sure that this is all scale. This scale, and likewise, we just want to make sure this is all at least nominal. If not ordinal, you want to keep it nominal, keep it. What I would prefer age is ordinal, for example, or age is nominal. Both are okay, depending what I want to do. Okay, so hoping that we understand, that how to start an SPSS and how to put data on SPSS and how to make these adjustments here. Now we are ready to do our preliminary analysis. And just to remind you, our preliminary analysis says that we should be doing the data screening. Can I do the? Okay, let me go back here. So let me show you my PPT file. So the first part we'll be doing the data screening. Once we collect the data, the first part we want to do is we need to do data screening. And why do we do data screening? Because this is the requirement for many type of analysis we run later on. Regression. We need to do that different type of process, data screening, to make sure that regression results are valid. If you're doing SAM, we call smart PLS. Same as there. We need to do a different number. We need to take a number of steps to do data screening, such as missing value, and then identifying missing value, and then doing the treatment, likewise identifying whether data is normal, and then likewise identifying whether we have outliers in our data, and likewise we're doing some type of they're doing something that we call common method bias. Okay, so in order to do so, this is we call data screening. However, before we do data screening, there's one more step we want to take, because there's some the two types of data is going on at a time. One type of data is as it is, we have on the sheet. And another type of data is that where we take, let me highlight it, where we take average of each variable, So we take average of all customer satisfaction, one, and then we take average of food quality, and then we take average of perceived value. So there are different type of analysis we run. On some type of analysis we run as it is on the sheet. On the other type of analysis we run on the average values of each of variable. Especially when it comes to regression, regression is run on average values. So let me show you what do I mean by average values. I'll show you how do I run it. Look here, I've taken average values of 3 for food quality, for customer satisfaction, perceived value. So, and let me show you how do I do it. So there are two ways. One way is that you can simply do it on Excel. On Microsoft Excel, you can take average value and bring them here. I don't recommend it. Like I said, there are some type of analysis that we need to run on average values, and some type of analysis that we need to run on the data as we collect, like you see on the screen. So let me show you how did I for this data, for this type of data, for each of variable, how did I took out the average value using SPSS. So let's go. Okay, I'm sorry. So let's go here. We go to analyze. We go to transform, and then we do compute variable. So again, we go to transform, go to compute variable. And what compute variable does, it allows us to do a number of different type of statistical analysis, customized analysis. So all I want to do right now is I just want to take the average value. Just want to take the average.
Doctor?
Yes.
Oh, we can't see SPSS.
You can't see. I'm sorry.
I'm
really sorry.
It's okay, but just want it.
Let me show you. Let me show you. Okay. So this was so I'll repeat because you were not able to see that. So this is where the data. This is the data. So we run we need two type of data when we're doing any type of analysis in SPSS. One is this data that we have collected from our respondent, and we have put them here. The other type of data is that when we take average value of each variable. So in this case, average value for customer satisfaction. And how we'll take average value? By raw wise. For each row, we take average value and we use that one. Same thing we can do, same step we can take for food quality, where we take average value for food quality. So instead of having 5 rows, 5 columns, we'll have 1 column. That'll be of average of everything. So let me show you here. So here I've already taken average value for food quality, average value for customer satisfaction, average value for perceived value. Now, to show you how we can take average value using SPSS, we can go to transform and we can use compute variable, right? So I've already done average value for 3 of my variables because I had 5 variables in my research. Customer satisfaction, food quality, perceived value, and then we have ambience, and then we have responsiveness. So because I just want to do the average value. The couple of ways we can do average value. One way is this. I can use simply. Let me show you first one way. I can simply do this. I go here and I write. Which one is that? The fourth one is AMB, and then underscore. When we're naming any variable, actually I'm naming my variable. What will be the new variable? That will be the average value. We cannot leave any space here. So we just need to make sure that there is no space. So AMB, ABE, and then simple here. I can do multiple ways. From here, I can select mean value, or other way around. If you're really not, for example, I can go here and I can select, I went here and I selected the statistical and I selected mean. As soon as I clicked on mean, this formula came there. And all I need to do is now select. Now it's asking me to add your variable. So I know the ambience is my target. So I put ambience 1 automatically, and then I'll select this and I'll select ambience 2. And I'll put comma, and then ambience 3, then again comma, then ambience 4, and then again comma, and then ambience 5. So you can see this. I am, this is going to take the mean value. So I'm taking mean value and I clicked OK. As soon as I clicked OK, Spss has this function. Every time you do, this output window comes out. I don't need this right now. I'll just click no, and look here what happens. Now I have a new variable here, ambience value, which is the average of what is this? Ambience? Okay. Which is the average of this. So for all these ambience, 5 column ambience, I have average value here. Okay. Same I can do. So let's do it again, and let me show you now how I can do it manually. I can do the same. Okay. So last one is RSP. So let's write for RSP. Average value. So I can do the same. If I don't want to do this way, other way around, you just simply, I'll do this. I'll go here, select. If I want to do manually, responsibility plus, again, I'm doing manually, plus, selecting and then putting plus sign, again, and then this, and then, okay. So everything was in parentheses, and then because these are the 4 variables, then divide by 4, and I'm sure it's gonna do the same again. Now, so now I have the average value for responsiveness as well. So we need to have 2 types of data when we're doing a Spss analysis. One data is the one that we're bringing from Excel sheet, which is as we have received from our respondent when we gave them our survey questionnaire. They gave us responses. So each of this rows represents the respondent. Respondent 1 gave this answer. Respondent 2 gave this answer. Respondent 3 gave this answer. Respondent 4 gave this answer, and so much and so on. And this data, we have taken average here for this data. So now we'll be running different type of analysis. So when we're running different type of analysis, in some of the analysis we'll be using this data, and some of the analysis will be using data. And with the expectation and hope that you understand, now I'll move on to my first part where I wanted to check missing values and treatment. And so first let's check. It often is the case that when we receive the data from our responses, from our respondent, often some of the values are missing. Some of the responses, respondent just don't give us responses mistakenly, or they forget it. What if this is the case? Like you see that there is no value. What if the case we have like this? So this respondent number 6 gave us a lot of information, all the data, but he or she forgot to give us response for customer satisfaction 4. If this is the case, and it is the case all over the data, this may put a huge question on the reliability and the validity of our data. So first step we want to take after we have collected data from our respondent, after we have collected our sample, the first thing we want to do is we want to run our analysis and check if there is any type of missing values in our data. So what I'll do, I'll go to analyze and then descriptive statistic. It has, there are multiple ways we can do it, but this is the simplest one. you go to analyze descriptive statistics, and I run frequencies. And all I do, I select, and notice I'm not selecting here this data, not this one. I'm selecting here this data, which is the data which is my non-average data. This is data before I took average. Okay, I'm selecting all this data here. I just want to see if if there's any data which is missing. Okay, and then I put that here. As soon as I put that here, came back. So what did I do? I selected all this and bring it all here, or other way around. As soon as you've selected, just hit this button, it will come here. So what we're telling Spss that ignore these variables and just run our analysis. The analysis we have selected, which is this one. Ignore all these variables here and run our analysis on these variables. Then let's go to statistics. Just leave everything as it is. Don't need to do anything. Just go here and then click OK. And then again, okay. Can you see this statistics, Miss Amal? Can you see this statistics table here?
Yes.
Okay, perfect. Okay, so now if you see, I just run simple frequencies, and look underneath each. This is showing each of my column. Customer satisfaction 1 0 says no missing value. Customer satisfaction 2 no missing value. 3 no missing value. Customer satisfaction 4 has 2 missing value.
Sorry, I think now it's stuck in the same picture.
Which picture are you talking about?
The values, the data view.
Data view? Okay, let me. Wait. Stop sharing. Okay, what I'll do, I'll just simply share my screen. So this problem is solved. Can you see now?
Yeah, now we can see the statistics.
Okay, because now I'm sharing my screen, so we're done. Anything I'll do, you'll be able to see now.
Okay.
We'll not have to change. Okay. So now, as when we ran this analysis, this is the table came out, and when the table came out, what happens is now this table is showing different type of information for each of the column on our sheet. CST1, column 1, CST2, column 3, if you remember, CST3, CST4, CST5. Now showing is, okay, it had the data of 208 responses, and it says it has no missing value, 0 missing value. And then 0 missing value for CST2, 0 missing value for CST3, but CST4 has 2 missing values. So the first step, checking if our data has missing value, and we figure out our data has some missing values. Likewise, we have missing values in FQ1. Likewise, we have missing value in FQ4, and then we have PV. PV1, we have missing value. Okay, so that means our data has missing value, and ideally, it is highly recommended that we do not leave any missing value. We do not have any missing value in our data, and if that's the case, what we want to do, we want to do a treatment for our missing value. So like I say here that we should be doing treatment. So let's do a treatment. So what is a treatment? Very simple treatment. So let's go here. Okay, let's go here. Transform. So first, I check my analysis. I ran my analysis from here. And now I'm going here to transform, and I'm going here to replace missing value, and I click on it. Now I need to select one by one, and if I remember, we had no missing value in 1, we had no missing value in 2, we had no missing value in 3, we had missing value in CST4. So let's click CST4, click it, select this, and then click here, and then now what's going to do Spss has CST4 satisfaction 1 already. So just like average value CST4, the Spss will create a new variable called CST4 underscore 1, and that will have, oh, actually I already have it. So let's put 2. Okay. I guess I already have CST41 somewhere. Okay, let me see CST41. I have CST41 somewhere. Why it's showing CST401? Do we have CST401 anywhere? No. Okay, let's go back to replace missing value. CST4. It says we already have it. I don't know how do we have it. Anyway, let's give it a different name. So CST4. Let's say we say this. Okay, no. Okay, no. Okay, NMS. That means no missing value. Okay, so and then we say so. This we selected and this, and then we hit change. So it changed. And then we select which method we want to use to treat this missing value. We have multiple methods. One is series mean. That means the total raw mean, whatever the series mean, whatever the raw mean is, whatever the raw average is. Other way is the mean of nearby points. The third way is the median. The fourth is linear. The fifth is linear trend of point. Most common is the series mean and mean of nearby point. I would rather select series mean, select this. I've already changed it, and as I click OK, and I click OK, and it shows me that it has created a new column, which is customer satisfaction 1 NMS, no missing value. It has 0 missing value. It has already treated. It has 0208 missing value. That means it has no missing value now. Let's check it. Let's check it. Let's go back. Analyze descriptive and frequency. Okay, I'll put all them here, and I have a new variable here called SM. Right. This is the new variable. This is the new variable, a new column we selected. In case you remember. In case you don't get it, look here. We have a new variable. We have a new column here. So because I have a new column here, satisfaction 1 NMS, I need to remove this first column here. This one. Sorry, 4. Okay, so we need to remove this. If we have missing value here, we need to remove this. Anyway, so let's check if it has removed the missing value or not. Let's check. Okay, so let's go here, frequencies. Let's select this here and run OK. It says 0 missing value, right? Okay. So same we can do with other variables. So let's go here and go back, and let's say we want to check missing value for all these. So let's check missing value for only food quality. And okay. And then food quality 1 has 1 missing value. Food quality 4 has 1 missing value. So food quality 1 needs to be treated. How will I treat? Again, no, and then I'll go transform, replace missing value, select, okay, and then I'll go to food quality 1. This has a problem of missing value. So food quality 1 underscore NMS, and then I'll hit the change button, and series mean is already selected. I'll select OK, and it shows that it has 1 missing value when it treated it. Okay. Now let's look here. Look here. It has treated. It has created a new one. So as a result of this food quality 1 NMS is here, so I need to remove this from there. Food quality 1. I should be removing this. Clear. Right? Because I have the new variable. I have the replacement column here, which doesn't have the missing value. So, and I can bring that here simply. I can just copy that here and bring it here. Okay, let's check if it really removed it. Let's check. Let's go here, go on, go here, and then I have food quality variable here. Let's check. It has no missing value. Earlier, it has a value. Food quality 1 has a missing value. So we are done. We're done with the first part. We're done with the first part where we are supposed to run missing values and check if there are missing values, and then run the treatment. So just like that, we should be doing the treatment for all of our variables. all of our value. Before we do anything, we need to check the missing value. So because our data has the missing value, it is highly recommended if your data has a missing value, uh, remove these average values from here that we have taken before. Average value, right? Remove them here. Okay. Remove them here, clear. And take average value again because the data had missing value, right? The data had missing value. And if you don't do that, it will be incorrect data. So because our data had earlier missing value, the average value will be different than with the average value we take now, right? Okay, I'm not going to take average value, but this is what the step is. First, check the missing value. Once the missing value are done, then run, uh, you know, uh, check if their data is normal, then check if your outlier is there. And once all of this is done, then you want to go ahead and run, take your compute here, go here and compute those average of each of your variable. So in that way, your data will be ready for the next step. Next step. So we're done with the missing value. Let's check if our data is normal. Let's check if data is normal. Now, there are a couple of ways people do normality of the data. Let me show you most common steps we can check if our data is normal. If our data is normal. Okay. So assuming that you understand what do I mean by data is normal, that means it is it's not highly skewed data. And if you don't know what do you mean by normal data, let me show you here. Let me show you here. Let me show you here. Ah, okay. Amal, can you see my screen?
Yes,
Yes, doctor.
we can see.
Google.
Okay. So let me show you what do I mean by normality plot. Let me show you what do I mean by data should be normal. Okay. It's taking a lot of time. Okay. So normal distribution curve. Ideally, a data should look like this. One of these, right? Look like this. That means our data should be, most of our data, 64% of our data should be somewhere in the middle. And then some of the data should be here, and some of the data should be here, and some of the data should be on the left side. What if our data is not like that? This is a normal distribution data. So when we collect the data, we check whether our data is normally distributed or not. This is a fundamental requirement for various type of statistical analysis. What do you mean by, so when the data is not normal? When the data is not normal, let me show you, non-normal data, highly or skewed data, skewed distribution, okay. So let me show you what do I mean by when the data is not normal. So in this example, on the one side, this is the left skewed data. If you can see, the data doesn't look like a normal, it is skewed from the left side here. And likewise here, the data is not normal because it is skewed from the right side here. Same is the case here, the data is a little bit skewed, right? So what we want to do, this is an example. So here you see the positive skew data, here you see the negative skew data, and here in the middle you see the normal distribution. Ideally, our data, when we collect our data should be normally distributed. In order to ensure that our data is normally distributed, we need to run different type of analysis to check if a data is normally distributed. So what I'll do, I'll go to analyze. Number one, I'll go to analyze, and then I'll go here, explore. Okay. And then I'll select all of our data. here, and then I'll put all this data into dependent. I won't do anything. I'll just put all of data here, right? I won't do anything. Just put this data, all data here, independent, and run OK. When you run OK, let's see what type of data, what type of analysis Spss shows us. It's taking a while. Okay. Okay. So now Spss has run different type of analysis. Number one, Spss has given us these values here. Let's ignore them. Let's go to descriptive straight. So now have a look at this. What is happening here? Spss is giving me for each of my column, each of my response, giving me different type of analysis. So Spss is giving me this analysis here. It shows me that skewness and kurtosis value. It is highly recommended. It is highly recommended that in order to check the normality of our data, we check skewness and kurtosis value. These are two types of tests that we often run to check whether data is normal or not. And have a look at this skewness and kurtosis for each of these items. Skewness and kurtosis is a recommended threshold is that skewness and kurtosis. The most common one is that it should be between minus 1 and plus 1. I mean, it should be between -1 and +1. And if you look here, it is 0.247, and the second one is 0.73. Second is 0.73. Okay, okay. The second one is 0.73. Okay, and then here CST2 we have kurtosis and skewness value is again is 0.001 and then 0.73. We'll not be looking at standard error. We'll be rather looking at the statistics here, and then kurtosis here is minus 0.88. Again, this is minimum. This is the given range, which is within the range, which is minus plus 1. However, this here, this is little bit out. This is little bit out. Let's have a look at other values. Other values here again within that, again within that, minus plus 1. Again here. Okay, this is a little bit out here, but it's okay. Don't worry about it. I'll let you know the other way around. Okay. So I guess most of your data is quite normal. This doesn't have much of a non-normality issue. There are a couple of threshold values. Some people believe that it should be minus plus 0.87. Other people believe it should be between minus plus 1 value. Other people believe that it should be minus plus 3. And if you assess these values based on minus plus 1, that means between -1 and +1, we realize that most of our values are a little bit somewhere they're exceeding somewhere, but in most cases they are within the range. However, we have another way here again within the range. We have another way of testing the normality. It looks like our normality, our data is normal, but we need to test it. We need to check it other way around. So there is another way, we call it histogram. I'll close it here. No, I don't need output. The other way is we can check where data is normal or not by checking through histogram. In order to do that, let's do this. Okay. In order to check, okay. Okay. So I'll go to analyze. I'll go to analyze and regression. Then I'll go to linear, and I'll select all of these. If you remember, and then select shift. Let's put all of these in the independent variable. Can I? No. independent. Oops, I'm making a mistake. Okay. So let's put what? Okay. Let me open, because in order to run this type of analysis, actually, I need average values. I need average values. Okay. Can I do it without average values? Okay, no, I can't. So let me open the other file. So this is the file where I have this is the final file. Actually, I should be using this one now. So let's open this file. It's the same data. It's the same data. The only difference is that I have already treated missing values, and I have already taken average values here. So let's go here in order to check regression and then linear. And I'll be using here average values, and I know customer satisfaction is my dependent variable, and I know these four are my independent variable. So what did I do? I went to analyze, regression, and linear. Then I selected average one. Customer satisfaction is my dependent variable, and then I have four other variables. And then I put in as independent variable, and then I go to statistics. I leave as it is. I don't do anything. I go to plot, yes, and I put dependent here. I say this is dependent. Let's say y, and then I put, let's say, this one on x variable, and I hit histogram. Okay. Then I continue, and I click OK. Now we're going to see a histogram. Graphically, we're going to see whether our data is normal or not. Because what kurtosis and skewness values were telling us, they're pretty much normal, but there were a little bit violation. And there you go. According to this, and if you remember, when we checked those normality curve, according to that normality curve, our data is pretty much normal. It's pretty much normal. So you can do the same. So you can do the same. If your data looks like this, it is neither highly right skewed or left skewed. Likewise, on top it is also quite equal. It doesn't have, quite many spikes here. We can say our data is almost normal. It's almost normal. Okay, so we check the normality of data. Let me take you here. We check the normality of our data by checking whether our data is within kurtosis and skewness values. The given threshold was -+1. And we also check our normality of data by using what we call standardized residual or unstandardized residual, whichever one you want to take, to check whether data is normal. And according to our analysis, it looks like our data is normal. So now let's check whether our data has any outlier. And what do you mean by outlier? Let me show you outlier. Okay, let me go again. Okay, outliers in data. So let's go to outliers. Let me show you outliers. How does an outlier look like? So I'll go to image, and this is a good example of outlier here. So if you collect all your data and you plot that on X and Y axis, and you see most of your data points are here, but some of your data points are here like that, well, they could be outlier. And if your data has outlier, that means these are outlier values. These values are completely different from your rest of your data. And the same you see here. This respondent has given completely different response from the rest of the respondent. Now, if you have this type of situation going on, if you have this type of issue in your data, this could again put a huge question on the validity of your result, because this is going to change the variance of your data. And if you know what I'm talking about, variance, mean, the mean, statistical inference, we understand standard deviation and variance. So if you have this type of value here, this is going to change variance, and most of the analysis that we run, they use variance. Regression uses variance. PLSM uses variance. And as a result, this will change our result completely. So it is recommended that we remove these outliers, remove these type of outliers. Now, so we have, so because we are in regression, we run multiple, we call multiple regression. So there is a method we call Mahalanobis distance we use to check multi-normality. Multi-normality means at a time we can check the data, we can check the normality of this data. And how do we check it? We check it by, number one, how do we check it? Let me show you how do we check whether our data has any type of outliers or not. Let's go to analyze. And regression, and then go to linear. Right now we have nothing to do with regression. We're just using this path to check whether our data has any type of outliers, right? So again, we remember the average values. So customer satisfaction is dependent variable, and then all these variables are independent variable, right? And then we go here. Oh, sorry. We go to options. Nope. We go to statistics. Nope. Where do we go? Plot. Nope. So we go to save. Okay. So we go to save. And then here you see under distance, you see Mahalanobis. Click on it. So I'm doing nothing else. I'm just selecting here. I go to regression, and then I go to save, and I click on Mahalanobis. I don't do anything. I just click continue, and then click OK. As soon as I click OK, this dialog box comes up. This results come. I don't need this result. I'll just close it. And look what happens here. It created a new table we call Mahalanobis MAH2, right? I already have it here, so MAH2. So let's clear MAH2 here. Let's clear here. Let's run it again. Linear. Everything is selected already. Okay, and then okay. And look what happens. I have a new variable here, MAH1. This is Mahalanobis distance. Now what I'll do, I will be sorting it as descending. And you see the highest values are here. Okay, let me remove this because this is I did before. Okay, so we have the highest values here. But the problem is we still don't know. Looks like these somewhere here we have the outlier values because the rest of the values are quite small. These are the highest values. But we don't know. We don't know for sure whether these are outlier values or not. That means whether these responses, this one, are outliers or not. Let's do another thing. I'll go to transform, and I'll go to compute, and then I'll go here all. Okay, let's do 1. I'll put 1 minus. So look here, I'm putting 1 minus. Then I'll be using here this CDF. This is chi-square value, and then 1 minus here, and then I click on CDF chi-square value here, right? And I put here. I'm giving it a name of probability. Okay. And then I go here, and remember this Mahalanobis, and it always asking me if chi-square is asking me. We are using chi-square test to check whether Mahalanobis values, which Mahalanobis values are telling us that there is an outlier. So we click on Malanovis. Malanovis values are here, and now it's asking further. This is asking me degree of freedom. Degree of freedom, very simple. We know that our independent variable are 4. So it's 4 minus 1 comes out 3. So degree of freedom is 3. And I click on whatever the number of independent variable is minus 1. So if you have 5 independent variable, then you'll be putting 4 here. If you have 6 independent variable, you'll be putting 5 here. I have 4 independent variables. I'm putting 3 here. This is degree of freedom. And then I click OK. As soon as I click OK, I have another value called priority here. Okay. So the rule here, and I'll go to variable view, and I'll increase the decimal to 5. The rule is any value that is smaller than 0.001. Any value that is smaller than 0.001, that is actually outlier value. So I see this is smaller than 0.01. I see this is smaller than 0.01. I see this is smaller than 0.01. Again, this. However, from now here onwards, I don't see the values smaller than 0.01. That means only these 3 are my outlier value. So rule is very simple. Smaller than 0.01. Smaller than 0.01 means these are outlier responses. So these 3 responses, according to our data, are outliers, and we should be removing them. We should be removing them like this, right? Clear. And they should be removed. Yeah? Okay. So let's go back here. So we're done with 2 parts. We are done with missing value 3. We're done with data normality. We're done with outliers. The last one is often the case when we're collecting data from survey questionnaire. Another issue is the existence or the occurrence in data called common method bias called CMV. Now, because I don't have much time to tell you what CMV, just simple as that, there are various ways that we figure out that too many people or same type of people have responded similar manner because they carry some type of bias. Whether bias is their personal bias, or bias is in the method of collecting data, or bias in the procedure of collecting data, or bias is because of our scale, the type of scale, or the questionnaire we have selected. There could be various reasons our data may have bias in it, and as a result of that bias, our results may inflate. In order to ensure that CMB or CMV, both means the same, there are multiple methods of doing it. Today there are multiple methods of testing it, whether our data has common method bias or not. Today we're testing, we're using Herman single factor test. And how I'll be doing Herman single factor test, let me show you. I'll go here, analyze, and then I'll go to scale, I'll go to factor reduction. Okay, diamond reduction, analyze, diamond reduction, and factor. And then I'll again be using these. There are 2, school of thought. One school of thought that when we're doing this type of thing, we should not be using dependent variable. The other one believe that we should be including in this type of test. We should be including our dependent variable. So I'm including dependent variable in this. Okay, and then extraction 1. Okay, principal component. There are a couple of some people use principal component even though it is for EFA. So let's me use principal access factoring here. I'm using principal access factoring here. I'm putting it fixed here, putting 1 number here. I'm putting continue extraction method. So, principal component. Covariance method, we can select covariance. Okay, and then rotation, varimax, or let's put it to none, and the rest just leave it. So descriptive as it is, cancel. Extraction, I put principal access here, fix to 1, continue, then okay. Now, looks like we did something here. Okay. So if you look here, so looks like our first row is explaining how much variance? 59% variance. If this is the case, apparently our data, if the value is more than 50%, looks like our data has the issue of common method bias. Because the recommended threshold is that it should be less than 50%. None of the variable here, I'm putting one variable here. Okay, let me do it again for you, just to show you. So I go here, down reduction, script statistics, continue, extraction. I believe that's the way to do it. It should be one. Just for component. Yeah, this is the way to do it. Okay. So we see here data extraction is 2.7, and we see the sum of the variance. The first variable, the first factor here is explaining 59.853 variance. Now this shows the issue of common method bias or common method variance in our data, because if any of our factor shows that we have the variance more than 50%, that means we have common method bias issue, right? Now, so we have common method bias issue, and now how to solve that? Obviously, that has a altogether different treatment that I'll now be covering here. But in most cases, it should be less than 50%. And if it is less than 50%, you can say that your data does not have common issue. Okay, so let me close it here. Let's go back. So we are done. We're done with the data screening. We're done. We have already taken care of missing value. We know the treatment. We've already tested the normality of the data. We already tested normality of the data. We already tested the outlier of the data. And we already tested whether our data has common method bias issue or not. Next we'll be doing, I'll be just skipping this because this is something you can do anyway. Next we'll be doing another issue is this, and it should be, it should be the part, this VIF value should be the part of this here. And let me put it here so you don't get it wrong. You don't get it wrong. So another thing we need to test is that whether our data has VIF issue. VIF. I'm writing here VIF. Okay. VIF. So another thing we need to test whether our data has VIF issue. So what is called VIF? VIF, in other words, check the multicollinearity of the data. Multicollinearity. What is multicollinearity? Multicollinearity means extremely high correlation between the variables, and as a result, this can inflate our variance. It can inflate our, it can provide us, invalid results. So how do we check VIF? That means multicollinearity. How do we check multicollinearity? Again, for multicollinearity, we do regression. And we use regression to check multicollinearity. Again, we have customer satisfaction as dependent variable. We have these variable as dependent variable. And go to statistics, and look here. I have collinearity diagnostic button here. And then continue. And then okay. Now we are zero interested in everything else. We just go straight to the coefficient. And we look at the VIF values here. So if you look at the VIF values here, right, all of these values are below 3.3. The most common VIF threshold value is 3.3. If your values of your data is less than 3.3, you can say your values, your data does not have VIF issue. Okay. So for example, I can create a bar graph here like that. Okay, so none of our VIF value is is above 3.3, so we can say we have no multicollinearity issue. So we are done with as far as our data screening is done, and now I'm moving to correlation. Let me remove VIF from here, because I don't want to confuse you. So let me okay. So now we'll be moving on to correlation. Now, why do we do correlation? Correlation is a common test. Itself is a statistical analysis, a statistical test to check whether there is some type of relation between variable 1 and variable 2. And as you can see here on the right side, this is a correlation. That's how correlation looks like. This is a positive, strong correlation. Now, how do we check correlation? Let me show you correlation. So we go to analyze, and again, correlate, and I go to bivariate. There are a couple of ways we can check correlation. We can check correlation between two variables or more than two variables. So let's say we want to check correlation between only customer satisfaction and food quality. So we go here, select this, and then continue. Pearson correlation should be selected, two-tail, and then select significant correlation. This is a simple one. So we have 0.732 correlation going on between customer satisfaction and food quality. What if you want to check correlation of all of our variables? Very simple, very simple. Again, we go here, analyze, we go to correlate, bivariate. Instead of selecting only these two, we'll be selecting all of our variables. Okay. Okay. Responsiveness, potential. So we have, how many variables we have here? We have, okay, so sample data, okay, it's not the final data. Okay, let's go to final data. So this is the final data. So I go to correlate, bivariate. Is the final data? Yeah. And then we go here. Why I can't see my other data? I have RSP here, I have CST, all the data is not showing. Okay, let's do it again. Correlate, bivariate, reset. Okay, right here. All this data is here. And I select all of this, and I select here, and again, same. Okay. Now I can see correlation between each of the variables in my reset model. And you see some of these values are 6.12, 6.656. Keep in mind that if the values are less than 0.20 or as low as 0.20, any value here. So this shows the customer satisfaction relationship between food quality, customer satisfaction relationship between perceived value, customer satisfaction relationship between ambience, customer satisfaction relationship between responsiveness. Any value which is, there are two opinions. One opinion says any value which is as high as 0.90, that is problematic. And any value which is as low as 0.20, it is problematic. In our case, we have significant correlation going on, but none of that correlation is too high or too low to affect our result, right? So this is correlation. This is we call correlation. So what if you wanna see the? What if you wanna see? Okay, can we do that? No, for that we need to go somewhere else. Means. Okay, so I just wanted to draw that correlation, but it's not possible from here. I'll have to go to the regression site and then I'll be able to do that. Anyway, so that's how we run correlation. According to these results, none of our correlation value is too high or too low to indicate there is any issue within our data. So we can move to the next part. So what is next part? So we're done with data reliability. So let's check the data validity. Now, oh, sorry, we're not done with data reliability. We need to do the data reliability now. So just want to make sure that I select the final data. Okay, final data. Now we'll be using this data here to check the data reliability. Now, what do you mean? You must have heard Cronbach alpha values and all those values. Basically, they all refer to data reliability. So how do we do data reliability? Let's do data reliability. We go to analyze, we go to scale, and then we select data reliability. Okay, so how do we do data reliability? We need to check it one by each concept or each variable one by one. We can't do it all together. So I selected customer satisfaction here, I put that here, and put statistics, right? I just want to make sure that I select something, item, scale, and then scale deleted. These three I've selected. I'm not selecting correlation here. Okay, continue, and that's it. Model alpha, yeah, it will remain alpha. Okay. So it's running my reliability analysis. I guess it's taking time. Okay. So after that, we'll be doing data validity and then. Okay, so we have the results here for reliability, and again, our focus is this. Our focus is our focus is this, and our focus is this. Okay, number one, have a look at the. Oh, sorry. Our focus is this table, and our focus is this table. So number one, have a look at it. What is the data value? Is 0.891. So we can say customer satisfaction has very high reliability because any value that's 0.708, they say it's a good value. We should have at least, or some people call it. They say even 0.70 is okay, and some statisticians believe that even 0.60 is okay. So according to 0.708 threshold value, our data, the values for the data reliability for customer satisfaction is pretty high. This is an important table. This table shows me if I remove any of these items, what will be the data reliability. So it shows me that if I remove CST1, the data reliability will come to 0.859. If I remove CST2, data reliability will come to 0.862. So much and so on. And I realize that I am already getting the highest reliability values, so there is no point I'll be removing any of my item. Okay, so let's do it again for another one. Let's analyze and scale and data. Okay, then I select. So reset. How about if we do for food quality? Okay, and then click OK. So the food quality, is it running? I guess it's running. Oh, oops, I made a mistake. Okay, I'll go back to food quality, scale, food quality statistics. Okay, this I forgot to select. Okay, and then continue and then continue. Okay, now look here. For food quality, I have data reliability. How much? 0.873, and shows me if I remove this variable, this item here, it will go up to 8.47. Here 842, 8.60, 8.25, 848. Well, while our data is already reliable for food quality, we don't need to remove anything. But in case your any of your variable gives you data reliability value less than 0.70, I recommend you go here, check which variable you can remove, and that will help you bring your reliability of your that particular variable as high as 0.70. Try to make sure that you have to minimum, try to make sure that try that you don't remove any variable. But if you have to really remove a variable, check different variable. Try to try that. You don't have to remove any of the item, but if you have to remove any of the item, try to remove as less as possible, because then it question the question the validity of your construct or your variable. Okay, so now I've showed you how to check the data reliability in SPSS. Now let's do the data validity. Now data validity is pretty easy, especially when you have taken, because in most cases we have adapted or adopted the data, and if that's the case, very simple, we need to do is we call it diamond reduction factor. You understand the factor analysis, it's common factor, outer loading, you must have heard outer loading, all that is factor analysis. So what we want to do in factor analysis, again, we'll be using this type of data. So let's say for customer satisfaction, I want to do factor analysis, for example, if I want to do. So let's put them here, and I go descriptive, I leave as it is, continue, I go to extraction, and then I put again here fixed to 1, and then even if I want a principal component, or I want to do, let's say I want to do principal access factoring, I would leave the principal component right now, and then go to continue, and then okay. Okay. So here our focus is this here. So here, as long as our values are above 0.70, we can say that our data outer loading, technically these are outer loading or factor loading values. So these values should be equal to 0.70 or above 0. Equal or above 0.70. Even some cases it could be 0.60. There are statistics out there who say it could be as low as 0.60. So in that case, our outer loading is 0.861, which is much above 0.60 and 0.70. So we can say that our data is valid, our outer loadings are high. Okay. So now this is only possible, the method I'm taking is called, EFA or CFA, called common factor analysis. I've taken common factor analysis here. So it is, in most cases we are doing, all the PhD student and master student, they are doing CFA. That means they're using a scale, they're using items of already published, they're using item from already published research. In that case, if you're using item from already published research, in that case, it's a CFA. In that case, this is the right way of testing it. So we can do again, let me show you again, we have to do with every other variable in our research. Go to diamond reduction factor, reset it, and let's do it on perceived value here, and then perceived value, and then everything else remains the same. Extraction, perceived value, fixed to 1, and then okay. Again, our focus is here. It shows me the outer loading or the factor loading as 0.78, 8.37, 0.79, except for PV5. Wow, PV5 has 0.574. Now it's my choice. If I want to remove it, I should be removing, because it's often a question that how can you use as low as 0.5. When you have certain type of construct, you can use it, but in reflective construct, actually you cannot use it. So it's recommended that we remove PV5 from our analysis and from all of our data, because the outer loading values are very, very low for this item. So we need to remove it from all of our data. Okay, so let me remove it. Let's go back here. So we're done with reliability and validity. Okay, so let's go here. So now we're done with the various aspects of running what we call data analysis, or we call screening for data a preliminary analysis where we did reliability analysis, data reduction, and correlation. And now we're ready for the main course of analysis where we'll be doing regression. Keep in mind, usually in most cases, we can do regression. We can do regression for only direct relationship in most cases. If you want to do moderated relationship, mediated relationship, or moderated mediation relationship, it's recommended that. Oh, I'm sorry, this got behind. It's recommended that we use PLSM or we use AMOS. For this type of it, I would recommend here. I'll be doing only the regression. So this one where you see. Let me show you. Okay. So here only direct relationship. This is something today we'll be focusing on. In order to do this, and this, I would recommend, even though we can use an add-on called process by Andrew Hayes, but I would still recommend that in order to run this type of analysis, if your model if a model or a conceptual model looks like this or this or this, I would recommend you use AMOS or Smart PLS. So today our focus will remain this direct relationship, and for that regression is highly recommended. So let's go ahead and do regression analysis. So keeping in mind that in order to do regression, we will need those average values that we have taken. So, and this is the difference when we run those mediated analysis or moderated analysis. Usually, Smart PLS or AMOS actually definitely they do not take average value. They have a different way of calculation. So let's go to regression and let's go to number one. We'll be doing. Let's go to. Okay, let me show you which regression we'll be doing. Number one, we'll be doing multiple or OLS regression. Okay, so let's go to analyze, regression, and then linear. Okay. So reset everything just to make sure you understand what I'm talking about. Customer satisfaction here, dependent variable, independent variable here, and then okay, so go to statistics. What we want to do, we want to have our square chain. No, we don't want to have it. Okay, continue plot. We don't want any plot. Save. We want standardize, unstandardize. Okay, sorry. We want these standardize, unstandardize. What else we want to do? Okay, this is okay. And then option looks okay, and then okay. So we are expecting. So our idea of this model, the model is that we believe that customer satisfaction is predicted by. That means we believe that the food quality have a significant correlation with customer satisfaction. We believe the perceived value of the service has a positive relationship with the customer satisfaction. We believe ambience has a positive relationship with the customer satisfaction. We believe responsiveness of customer service has a positive relationship with customer satisfaction. So if we have hypothesis going on like that, then we have the direct relationship going on, then we can run this coefficient, we can run regression analysis. In regression analysis, our focus remains on these two type of table. Number one is model summary, and then number two is coefficient. So model summary explains us the R square value, R square and adjusted R square value for, this is something, the overall value, how much overall these four variables predict customer satisfaction. So according to this shows that dependent variable, customer satisfaction, and predicted variable are constant. These RSP and all these, ambience and perceived value. According to this, all these four together predict how much 0.79s and adjusted R squared. Often in regression, we put more emphasis on adjusted R squared than the R value. So according to this, overall they predict 0.628. That means 62.8% they are predicting. But still, we don't know whether how much each variable is predicting and whether each variable is making a significantly predicting the dependent variable. For that, we need to look here, and the first is the constant. We just need to ignore it. And here, FQ means food quality, such as beta value and unstandardized value. We can have a look at. Let's have a look at unstandardized value. So it says that 0.476 is the weight of it, and it says t value is this, and then it says significant. So any value that is less than 0.055 is less than 0.05. We can say that data has a significant impact on dependent variable. So here we see the FQ has a significant relationship with dependent variable, which is customer satisfaction. That means our hypothesis, which said that the food quality has a significant impact on dependent variable, which is customer satisfaction. That is approved, and we reject null hypothesis and we approve the H1, which is alternative hypothesis. However, the same is the case for perceived value, where beta value is 0.177, t value is 3.1076, and the significant value is less than 0.05. As a result, we accept this hypothesis as well. However, our hypothesis for ambience has turned out to be false, because significant value is much bigger than 0.05, and as a result, we accept the null hypothesis that ambience has no impact actually on customer satisfaction, and we reject the alternative hypothesis that ambience has a significant positive relationship with customer satisfaction. Okay, so we're done with this is called ordinary least square method that we have run, also called multiple regression. So let's do the last one for today. So let's do another one, and that is logic regression. So why do we do logic regression? Okay, let me show you first, and then we'll figure out what is logic regression. So how do we do? We go to again regression, and then we go to binary logistic. Now, usually logistic regression is used when we have definitely. I mean, this is something important, that we have dependent variable which is binary or dichotomized, or it is 0 or 1, that type of. If we have this type of dependent variable, we cannot use logistic regression. We cannot use multiple regression. We should be using logistic regression. So in this case, I'm using here private and public firm, and my assumption is that basically I've taken data of the same customer that have given me data for this. I've also asked them whether you'll be more interested to select private bank or public bank. So private and public here, private and public, and let me show you what I've done for private and public. I'll go here, private and public, and look here, private and public. For public is 0, and for private is 1. Okay, so we are interested in predicting whether we can predict regression, and then whether we can predict using a data, we can predict whether these people our respondent will be selecting a private bank or public bank, right? And let's assume this data also comes from there, right? This also comes from there. So put them here, okay, and then dependent here, all these variables here, method is enter, categorical, I don't have any categorical here, so no need. Save, no, I'll just leave as it is. Option, I'll select Hosmer, and I'll select this here. and I'll select continue, and I'll select OK. So we're predicting. So we're predicting whether predicting on based on our continuous variable, based on our liquid scale variable, we're predicting whether these customer will be selecting public bank or private bank. This is the idea. So logic detection requires always a binary or dichotomized variable, a dependent variable. While independent variable could be anything, they could be dichotomized or continuous or liquid scale, but that's okay. Number one, have a look at here. Number one, have a look at here. This is something very simple. The type of number of data, everything. They're saying dependent variable. They're saying public is 0 and private is 0. Block 0. This gives us the idea that if we ignore public and private and they try to predict how much the data predict, they said the data predicting only 57.6% response of the customers. Okay, and this will be very handy when we'll check it later. And let's come down here. Let's come down here. Not an equation. No. Let's come down here. Where is that? Okay. So this is the fitness of our data, and fitness of our model says that omnibus test model shows us the data we have achieved good fitness of our model, and this value should always be bigger than 0.05, and in this case his value is 7.94 or much bigger than 0.05. In that case we can say our data is it is fitness of model data is there. Okay, let's have a look at now. Okay, so this was block zero, variable non-equation. Okay, and this is has test again. This should be again much bigger than 0.05. This is again fitness test. How much our data is fit. Okay. Now we want to check. So our focus should be here and here now in these two. Now we want to check how much our data is predicting, how much our data can predict whether these respondent will select public and private. And according to this, shows that our data predicts that these people will be selecting 95% correct with the accuracy of data is 95.8% when it comes to predicting whether these customers will be selecting private banks, and it says the accuracy of data is 95.8%. But for the public banks, our accuracy of data is 5.7%. So we should not be using that data for public. Rather, the same data gives a very high predictability for the private banks. However, which is very good, and overall is 57.6%. Overall, it's not very high, but for individual, it's very good. However, if you want to know how much each of this variable, contributing to the prediction whether these people will be selecting private bank or public bank, so then we need to look here. It says food quality. What the rule says that any value that is above 1 is good, and any value that is above 0 is bad. And if you look here, XP value, any value above 1 is good, equal to or above 1 is good, and any value less than 1 is bad. So according to this, food quality has a high significant contribution. Likewise, ambience is a high significant contribution, but for the rest, perceived value hasn't been able to predict much whether if these people will be able to select private bank or local bank. So is the case with responsibility. So in this case, food quality and ambience has a significant contribution to this prediction. Okay, that's about it. To the best of my ability, to the best of the guidance that Dr. Wasim actually gave me. I tried my best to stick to those points that Dr. Wasim had asked me, and this is what I've done. So I've gone through most of the analysis within I believe 1 hour and 45 minutes, and I'm open for the question.
Thank you, Dr. Kashif, for this informative workshop. We really got many information in SPSS that's crucial for our journey in PhD or any research journey. So now we open for the question. Anyone want to ask Dr. Kashif in SPSS? Or is there any question in the...
If there's any question in the comment box, no, there is no question in the chat.
Yeah, so far no question. So if there anyone want to ask, just can put it in the question and answer box.
Usually, a participant takes a while before they start questioning. So let's wait. I think they will question. They may have some questions. Thank you. Thanks a lot. I'm humble.
Yeah,
I'm humble. I'll be happy if you have any question. I'll be happy to answer them.
Here's someone from Annie Swan.
Yes, I read the question. Aniswan, thank you for your question. Definitely, you can do it. Spss is very powerful. You can do much more than this. You can do much more. Yes, you can.
So if anyone, if there is no question till now, so we can proceed. We have a small speech from Mr. Kamal. Kamal is still with us, right?
Amal, can you? Okay, my research involved more. Must it be done through PLS? Okay, well, please, Dr. Kamal. Yes, please.
Yeah. He can. Sorry, Mr. Kamal. We can't hear you. Can you unmute?
Okay. Alhamdulillah, thank you. Good evening, our respected trainer, Dr. Kashif Farhat, for the whole. Okay. Everyone, those who joined this workshop, and as representative for this program organizer, I would like to thank for the time Dr. Kashif Farhat has spent with us. More than 2 hours. Okay, Alhamdulillah. We appreciate all the sharing given, and I believe all participants get benefit and develops their knowledge regarding Maybank Research Clinic Statistical Package for the Social Sciences, SPSS. Alhamdulillah. Thank you, Dr. Kashif, and thank you all the organizers.
Thank you. Amal, I have a
Thank
small bonus. If nobody has a question, I have a small bonus. It will take a minute. If you allow, I'll do it.
Yes, okay.
Yes, sure, doctor.
Yeah,
Just
sure.
Just give me a second. Okay. Let me close my SPSS. Okay. Basically, this is about specifically about figuring out what sample size a student needs, or a PhD student needs. In other words, in order to determine the sample size of your research, this is something that not many people understand how to do it. For that, what I'll do, I'll just share my screen. Go ahead. To help them understand how to do it. And let's go screen. Okay. Okay. Can you see this now?
Yes, we can.
Yes,
Okay. Okay.
Yes, Doctor.
So now, the couple of things I'll tell. Number one, in business management, it's almost, in most cases, it's almost impossible to do research on population. That means we have the data of each and every member of our population. That's not possible. As a result, we usually go for sample. So when we go for sample, there is another high probability, which is that we go for a non-probability sample. That means we go for convenience sample, we go for purposive sampling, we go for quota sampling, whatever type of sampling we're doing. But we need to understand, as long as it is non-probability sampling, we can use G power. We can use G power to figure out. We can use G power to figure out what sample size, minimum sample size, do we need. Whether we're doing PLSM, we're doing regression. Actually, for regression, the minimum sample size should be 200 something. Especially when people are doing PLSM, they're always confused. Okay, what would be sample size and how to determine sample size? Don't worry. If you know, it's a good practice that you do probability sampling. But in most cases, business management, we cannot do probability sampling because probability sampling requires, number one, to know exact number of population, size of the population, and also the sample framework. And if you can Google what sample framework, that means you have the information and access to each member of your population. That's not possible in most cases in business management. As a result, we go for non-probability sampling. Now, in order to do non-probability sampling, we have two approaches. Let me show you. Actually, we have one approach right now, because if somebody who has not collected the data, then they need to run a type of analysis call. So they haven't collected data. They want to know what will be the sample size they should be collecting. So they should be using this software called G Power. It's a free software, anybody can download, and come here and go to this t-test, select t-test, and then go here and select. Okay, let me remember. Linear multiple regression, between slope, correlation. I'll have to recall what was two groups. Linear multiple regression, fixed single regression. Yeah, this is the one. Linear multiple regression, fixed model, single regression coefficient. Okay, so they can use this one. Okay, so t-test. Okay, let's check on f-test. What we're getting f-test. F-test, ANOVA, linear regression. Okay, so let's do f-test, not t-test. Okay, let's do f-test, and then go to linear multiple regression, fixed model, or deviation from zero. Okay, and then select a priori. This is specifically for the time that you have not collected the data yet, and you want to know what type of, what should be your minimum sample size. And then here, effect size, and if you look like select, it should be medium 0.15, should be 0.05, this should be 0.95, and this is a tricky part. Here you need to put your predictor variable. How many variables you have? Let's say you have predictor variable, not dependent variable, don't count that. So let's say you have 4 predictor variables. You have 3 independent variable, 1 mediation. That means 4 predictor variable. What if you have 1 mediation, 1 moderation, and 3 independent variable? That means if you have moderation going on, then you have another one. That means you have another one. So 3 mediation variable, 1 mediation variable, 3 independent variable, 4, 1 moderator variable, 5. Another variable that will come as a result of moderation, because moderation multiplies. That means 6 variable. So if somebody has 3 independent variable, 1 mediator variable, and 1 moderator variable, all these come together as a 5. And for moderator variable, because it's a 1 moderator variable, we'll add 1 more variable. That makes 6 predictor variable. So I'll put 6 here. And accordingly, you can adjust accordingly, however your model is. And I'll put 6 here, all these values, f-test, all these, and I'll put calculate. As soon as I calculate, look here, this gives me this diagram, and this gives me these values, right? A student can take a screenshot of this and put this screenshot in their proposal defense and methodology. In proposal defense, when they're going proposal defense, in their methodology section. And look here, we have a total sample size. They're saying if minimum sample size somebody needs is 146. So if after removing everything, if you're running final data analysis on 146, you can be sure that your data has enough significant significant power. So just look at here. It says 0.95 power you'll have. So this is perfect. So in somebody else's case who has eight predictors, let's calculate. In that case, they should have 160 minimum sample size, final sample size, and that will have the power of 95% of predicting it. That's about it. I just wanted to share with you guys. So somebody who is, uh, considering how to figure out what is the sample size, this is quite helpful for them. If they're going for non-priority, they should be using G power. That's about it.
Alhamdulillah. Thank you, Doctor.
Thank you.
Yeah.
Thank you,
Thank
Doctor,
you, Doctor.
for
Thank
this
you, Doctor.
informative.
Thank you, doctor, for the additional information.
Yes.
Thank you once again
You're welcome.
from my
You're
team
welcome.
as well.
Okay,
You're
Alhamdulillah.
welcome. Thank you, Dr. Amul. Thank you, Mr. Kamal. Thank you,
Yeah.
Dr.
Thank
Kashif.
you.
Thank you very much for inviting me here. And most definitely next week again on April 12, we'll be meeting, and there we'll be
Inshallah.
taking care of PLS.
Yeah.
Right?
Yeah.
Okay,
In
inshallah.
case you get any question, just forward it to me. Forward to my email address. Let me write my email address for everyone here. Kashif.
Yeah, sure.
Farhat@gmail.com. Somebody has any question regarding this or something else? If I can help you, I'll be happy to help you.
Alhamdulillah. Thank you. Thank you, Dr. Kashif.
Thank you, Doctor. It's
Okay.
our pleasure to have you here, and we
Thank
are
you,
looking
Dr.
forward for the
Kashif.
next
Thank you very much.
session, inshallah. And if everything done, we can also can finish this workshop. And also we went again in the next session.
Okay,
Next,
inshallah.
inshallah. Thank you so much,
Okay.
Dr. Kashif.
Thank you.
Thank you for SLDC team. Thank you for our attendance for the attendance, and that's all. Assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum assalam.
Thank you.
Thank you.